Last time we learned about square roots in prime factorization. Today we're going to learn something about cube roots in prime factorization. So let me remind you of what we learned last time. So we had a number like maybe 49, and we wanted to calculate the square root of 49, and that we said was equal to 7. And the reason why we said this was true was because when you square 7, you get 49. So that's what it means, that the square root of 49 is 7. Okay. Now, clearly, there's nothing very special about multiplying 7 two times. We can multiply 7 three times. So let's say if you can start multiplying numbers three times if you want to. So let's try another thing. So let's see, if we have a number like 2, we can multiply 2 three times. And if we multiply 2 three times, we call it 2 cubed, which is equal to 8. And cube refers to the power 3. Similarly, if we have 3, we can multiply it three times, and that will be 3 cubed, and 3 cubed is 27. And if we take 4, we can multiply it three times again, and the notation that we have for this is 4 cubed, which is 64. And these guys are called perfect cubes. So all these numbers are called perfect cubes. Okay, so 8, 27, 64 are perfect cubes. Now, exactly like 49 is a perfect square, 27 or 64 is a perfect cube, and now we can say uh, we can look at the inverse mathematical function. What it is going to do is that if you want to, so since 8 is equal to 2 cubed, we can say that the cube root of 8, and this is how you write the cube root of 8, is equal to 2. And similarly, 27 is equal to 3 cubed, so we can say that the cube root of 27 is equal to 3. And for 64 also is 4 cubed, so we can say that the cube root of 64 is 4. And this symbol, this entire symbol is called the cube root. Cube root. Okay? So now you can clearly see not all numbers have whole number cube roots, and we'll worry about it in a while. But now let's think about how can we use prime factorization to help us calculate cube roots when they exist. So let's look at a number like maybe 216, and we want to figure out the cube root of 216. Okay, that's a question that we're trying to solve. Well, we know something. We know the prime factorization of 216. It takes a bit of work, but it's not too hard to do. It's actually 2 into 2 into 2 multiplied by 3 into 3 into 3. So this is the prime factorization of 2 cubed. And now note, we have to find a number. The cube root of 216 is that special number that if you multiply by itself three times, you're going to get 216. And you can clearly see that you have three threes and three twos. So if you put a 2 and a 3 together, you are going to get a number which is 6. And if you multiply 6 by itself three times, you're going to get 216. So we can say that the answer is that the cube root of 216 is equal to 6, which really means that 6 cubed is equal to 216. Okay. Now, we did a very similar exercise in which we use prime factorization for square roots, in which we use prime factorization to calculate the square root. And what we learned was that we had to divide powers by 2. And the reason why we had to divide powers by 2 is because when you multiply, the powers add. So now here, so let's think about a problem like maybe a large number. So let's say I want to figure out, let's clear out the, let's use white. So let's say I want to figure out the cube root of this really large number, which is 31,255,875. Okay, this is a pretty big number, and I want to calculate the cube root of this number. Well, so here's a question mark. So it turns out that Fairy has told you, has whispered in your ear, that the prime factorization of this number is 3 raised to the power 6 into 5 raised to the power 3 into 7 raised to the power 3. Okay. So now I want to find out the cube root. Now note I want to find a number such that when I multiply by itself 3 times, I get this large number. So clearly, what I'm going to do is I'm going to divide 6 by 3 and I'll get 2, and I'll divide 3 by 3 and I'll get 1, and for 7 also I'll divide 3 by 3 and I'll get 1. So you can see, hopefully, that the cube root of this number, which is 3 raised to the power 6 multiplied by 5 raised to the power 3 multiplied by 7 raised to the power 3, and I want to calculate the cube root of this number, is going to be equal to 3 raised to the power 2 multiplied by 5 raised to the power 1, which is just 5, multiplied by 7 raised to the power 1. And please note that this 2 is this 2, and this 1 is this 1, and this 1 is this one, right? So what we're really doing is, and the reason why this is true is because, for example, if you look at the power of 3, please note that just as a reminder, 3 raised to the power 2 multiplied by 3 raised to the power 2 multiplied by 3 raised to the power 2. These are two 3's that are being multiplied, so this is going to be 3 raised to the power 6, exactly what we wanted. So 3 raised to the power 2 will be multiplied by itself 3 times, will give to 3 raised to the power 6. Similarly, 5 raised to the power 1 multiplied by itself 3 times will give you 5 raised to the power 3, and 7 raised to the power 1 multiplied by itself will give you 7 raised to the power 3. Okay, now you may be thinking, what's so special about multiplying a number by itself 3 times? So you can, in principle, multiply a number by itself 4 times, although we are not going to worry about it, and I'm not going to talk much about it. We did this is the idea of the nth root, but right now, for example, I'm just going to write this down. I'm not going to worry too much about it. So if I want the fourth root of 81, then that's just equal to 3. Why is that? Because 3 raised to the power 4 is equal to 81. So we can generalize this idea. Okay, but we're going to ignore this for now. So hopefully you've understood something about how cube roots can be calculated using prime factorization. I would suggest that you do some practice with your teacher or with the help of your book. Thank